Hello guys, welcome to H₂O, the A to Z of chemistry. I am Dr. RITU JOHAR, your educator for this course. Some basic concepts of chemistry. Today we will begin with lecture 13 from the course, but make sure you have watched the previous ones before viewing this one. In the last lecture, we had started the topic of equivalent concept, where we learned about the equivalent weights of various substances. Now, do you know what is the origin of these chemical equivalents? Well, this is our topic for discussion for this lecture, wherein we will be discussing about the definition of the chemical equivalents and some numericals based on these definitions. And then we would be discussing another important term, that is normality, in relation to the concentration of solutions. So where do we find the origin of these chemical equivalents? Well, it is found in the laws of chemical combination. Most of the compounds in nature, they exist as compounds of hydrogen or oxygen. For example, we have sodium hydride, we have HCl, we have water, we have ammonia, and so many compounds of hydrogen. And then we have so many compounds of oxygen. For example, sodium oxide, magnesium oxide, calcium oxide, carbon dioxide, sulfur dioxide, again water. So we have so many compounds of hydrogen and oxygen. So the equivalent weight of a substance was thought to be calculated in terms of chemical combination with hydrogen and oxygen, and then later it was extended to combination with chlorine. So let us see what is the equivalent mass of a substance in relation to hydrogen, oxygen and chlorine. So the equivalent mass or weight of a substance is the number of parts by weight of it, which combines with or displaces directly or indirectly 1.008 parts by weight of hydrogen, 8 parts by weight of oxygen, or 35.5 parts by weight of chlorine. Can you identify these numbers? Well, 1 in relation to hydrogen is the equivalent weight of hydrogen, 8 is the equivalent weight of oxygen, 35.5 is the equivalent weight of chlorine. And whatever the substance weight is combining with the equivalents of hydrogen, oxygen or chlorine becomes the equivalent mass. Right? So I hope you can understand all this. The reason why we are doing the original definition after discussing the whole of the equivalent concept was this. So that now you can identify why we have taken such weights of hydrogen, oxygen and chlorine, and then comparing the weights of the other substances in relation to this. This is because now you can identify that this is the equivalent weight of hydrogen, 8 is the equivalent weight of oxygen, and 35.5 the weight of chlorine. So the equivalent weight of the elements, they can be expressed as the equivalent weight of an element is in terms of hydrogen, weight of the element divided by weight of the combined or replaced hydrogen into 1.008, right? And if you just try to twist this, what will you get basically is that if you take this weight of combined or replaced hydrogen to the other side, what would you get? You would get the weight of combined or replaced hydrogen and then get the 1.008 beneath it. You will get the equivalent weight of hydrogen below. So weight of hydrogen divided by the equivalent weight of hydrogen. Similarly, on the other side, what would you get then? Weight of the element divided by the equivalent weight of the element. So this would be what? This would be the number of equivalents of hydrogen are equal to the number of equivalents of the element. And this is already you have done that, right? So I hope you can understand where we are coming at. So the equivalent weight in case of the element for relation to oxygen would be what? The weight of the element divided by the weight of combined or replaced oxygen multiplied by 8. and you know that the equivalent weight of oxygen is 8. O2 negative 16 divided by the Z factor 2 becomes 8. And then similarly for chlorine, it would be the weight of element divided by the weight of combined chlorine multiplied by 35.5. So I hope this is clear to you. We can understand this further with an example. We have zinc plus H₂SO4 forming zinc sulphate plus hydrogen, right? So we have 65 gram of zinc, 98 gram of H₂SO4, hydrogen being formed or coming out of this H₂SO4 is 2 into 1.008 grams. So now according to the original definition, the equivalent weight of the element would be the weight of the element divided by the weight of combined or replaced hydrogen multiplied by 1.008. So this would be weight of the element or weight of H₂SO4 if we want to find the equivalent weight of H₂SO4. So this would be 98 divided by weight of hydrogen, that is 2 into 1.008 multiplied by 1.008. So what do you get? You get 49 grams. And then you already have found it out that the H₂SO4 equivalent weight is what? This, it is 49 grams. If you see the number of ionizable H ions in H₂SO4, it is 2. So 98 divided by the Z factor, you got 49. And then according to the law of chemical equivalence also, you have seen that the number of equivalents of the reactant are equal to the number of equivalents of the product, where the number of equivalents are mass of the sample over the equivalent mass. Hence, the number of equivalents of H₂SO4 have to be equal to the number of equivalents of H2. So this what you would get, 98 divided by the equivalent weight of H₂SO4 equal to 2 divided by the equivalent weight of H2. And what is the equivalent weight of H2? Molar mass divided by the Z factor. So if H2 gives 2 H ions, 2 moles of H ions, the Z factor would be 2. So 2 divided by 2 is 1. So the equivalent weight of hydrogen is 1. So substituting here 1, you get 98 divided by 2 into 1. Again, you get the equivalent weight to be 49. So I hope what all ways we calculated the equivalent weight, they are now clear to you. Next, what we can do is we can define the equivalent mass in terms of volume also. So now from the mole concept knowledge also, you know that the mass of 1 mole is of a gas is equal to 22.4 liters at STP, right? You remember that? So we can similarly in terms of volume define the equivalent mass also. So the equivalent mass of the element is defined as the number of parts by weight of the element that combines with or displaces from the compound 11.2 liter of hydrogen gas, 11.2 liter of chlorine gas, or 5.6 liter of oxygen gas. Right? So if you are replacing the mass of hydrogen by volume, you will replace the weight of the equivalent weight also by the volume of that equivalent. So if H2 hydrogen gas has a volume of 22.4 liters or 22,400 ml, so 1 gram of hydrogen gas would be 11,200 ml or 11.2 liter. Similarly for oxygen, we had 8 grams over here. So 8 grams would be equal to 5.6 liter. And again for chlorine, so chlorine we have 71 grams would be 22.4 liters. So 35.5 would be 11.2 liters. So this is how we have converted the mass in terms of volume. So you are going to remember these formulas also. They are easy to remember if you know the mass and you know how to convert the mass into volume in case of a gas at STP. So I hope this is all clear to you. So now let us do a few numericals based on these definitions that we have learned. So the numerical one says 0.4 grams of magnesium is completely dissolved in dilute H₂SO4 and 235 ml of dihydrogen gas was collected at NTP. Calculate the equivalent weight of magnesium. So here we will be comparing it magnesium with hydrogen. So we get the equivalent weight of magnesium to be the weight of the metal divided by the volume of hydrogen at STP multiplied by 11,200 because the volume of hydrogen is in ml. So substituting the values, weight of the metal 0.4, volume of hydrogen 235 multiplied by 11,200, we get the weight of magnesium to be approximately 19 grams. So the next numerical says that 2.182 gram of tin oxide was completely reduced when 1.72 grams of metallic tin was obtained. What is the equivalent weight of tin? So here, because we have oxygen, so we will be comparing the weight of tin to that of oxygen. So we have the equivalent weight of an element with the weight of the element divided by the weight of combined or replaced oxygen multiplied by the equivalent weight of oxygen, which is 8. So here we will get 1.72 as the weight of metallic tin, and then we are not given the weight of oxygen. So how do we get the weight of oxygen? We will get this from mass of the oxide, which is 2.182 minus the mass of the element 1.72. From here we will get the weight of oxygen. So this you on solving you will get as 29.78 grams. The next question says 0.3975 gram of an oxide of a metal lost 10.06% of its weight when heated in a current of pure and dry hydrogen and was completely reduced to metallic state. What is the equivalent weight of the metal? So we have the metal oxide, which on heating in presence of hydrogen gets converted into metal plus water. Right? So what is the weight lost by this metal oxide? That is 10% of 0.3975. This comes up to 0.04 gram. And what is the loss here from being converted from the metal oxide to metal? So this is basically the weight of oxygen. So the weight of the metal is going to be 0.3975, the weight of the metallic oxide minus the weight of oxygen, which we get to be 0.3575. Hence the equivalent weight of the metal, which is the weight of metal divided by the weight of oxygen into 8, this we will get as 71.5. The next question says that a metal forms sulphate isomorphous with white vitriol. If its equivalent weight is 29.4, find the atomic weight of the metal. So first of all, what you need to know is what is the meaning of the word isomorphous. So isomorphism, we have compounds having similar molecular formula and identical crystal structure. They are called as isomorphous compounds. For example, if you see the compounds H₂SO4, H₂CrO4, H₂SeO4, these have a similar molecular formula, hence they are isomorphous. And now in our question we have a metal sulphate which is isomorphous with white vitriol. White vitriol is zinc sulphate. So the metal is also going to form a sulphate just like zinc sulphate. So the valency of the metal here would be +2, right? MSO4, just like ZnSO4. So the formula is MSO4, the valency of the metal is 2. So the atomic weight, which is the Z factor into the equivalent weight, so we get is 2 into equivalent weight. So here we would be getting the atomic weight as 58.8. So the next question says that 10 gram of a metal carbonate gave 5.6 gram of its oxide on heating. What will be the equivalent weight of the metal? Here now, what is it going to be? The number of equivalents of the metal carbonate and the metal oxide, they are going to be the same. So you can say basically that the weight of compound 1 over the equivalent weight of compound 1 would be equal to the weight of compound 2 over the equivalent weight of the compound 2. Right? We have just simply rearranged that number of equivalents to be weight of compound 1 over the weight of compound 2 and then equivalent weight of the compound 1 and the compound 2. And the compound 1 equivalent weight, how can you find that? The equivalent weight of the metal, which we are saying this to be E, and the equivalent weight of the anion in compound 1. In this case, the anion, first case would be carbonate, and in the second it would be the oxide. So just substituting the values. So we have 10 gram the weight of compound 1, which is the metal carbonate, and 5.6 the weight of the metal oxide. This would be equal to E plus 30. So the carbonate ion, this carbonate is molecular, the mass is going to be 60. So 60 divided by the 2 charge on it, we will get the equivalent weight to be 30 of the carbonate ion. And then of the oxide, 16 divided by 2 is 8. So we get E plus 30 over E plus 8. Solving E, what are you going to get? You will get this as E equal to 20 grams. So I hope I am clear to you. Basically here we are just equating the number of equivalents. The number of equivalents are going to remain the same. So these formulas really help doing your questions. So now this question says that 0.3834 gram of chloride of a metal when dissolved in water and treated with excess of AgNO3 solution precipitated 0.5276 gram of silver chloride, and you have to calculate the equivalent weight of the metal. So again, what you are going to do, the number of equivalents of the metal chloride are going to be equal to the number of equivalents of silver chloride. Even if you do not know the whole of the reaction, you can solve it this way. But understanding the reaction, we have that MClX, we do not know what is the valency of the M. So we have MClX plus water. Then this reacts with AgNO3 to form AgCl. Right? We have not written the complete reaction, but this is what was given to us in the question which we have written. So now the number of equivalents of the AgCl is equal to the number of equivalents of the metal chloride. So we have the weight of AgCl given to us. The equivalent weight of AgCl you can calculate, and then the weight of the metal chloride is given to you, and you can calculate the equivalent weight of the metal chloride. So from this, the weight of the equivalent weight of the metal chloride comes up to 104.28. Now this weight is going to be the sum of the equivalent weight of the metal and that of the chloride. So you get the equivalent weight of the metal to be 104.28 minus 35.5, which is the weight of chloride ion, and you get the answer to be 68.78. The seventh question is that 0.514 gram of a metal when treated with excess of H₂SO4 liberated 240 ml of hydrogen at NTP, and we have to calculate the equivalent weight of the metal. I have tried to give as many numericals I can so that you can practice a lot with me, and then you can do as many questions as you want from whatever books you want. Okay, so you will have a confidence in you that yes, you can do so many questions. So weight of the metal we have is 0.514 grams. The volume of hydrogen is 240 ml. So the equivalent weight of the metal, again simple, weight of the metal over volume of hydrogen into 11,200, and you get the answer to be 23.99 gram. So I hope the whole of the equivalent concept that is very clear to you. We have understood it as the charge form equal to 1 valency, how we have equated the equivalent concept with the different reactants and the products. Only the thing you have to do is that the number of equivalents are going to be equal, and then you have understood the definition of the equivalents as it was given originally in terms of the combination with hydrogen, with oxygen and chloride. So I hope all this is really clear to you. So now we will move on to the next, which is normality. Okay, so normality denoted by the letter N, capital N, is what? It is basically the brother or sister of normality. So what do I mean by that? Basically, whatever place we are using molarity in the mole concept, we are going to use normality in the equivalent concept. For example, the definition of molarity is number of moles of solute dissolved per liter of the solution. So normality is the number of equivalents of the solute dissolved per liter of the solution. So this means that N is equal to number of gram equivalents of the solute divided by volume of the solution in liters. In normality, it was simply number of moles, okay, instead of the number of gram equivalents. So we can write it in the symbol form. N is equal to EQ, where EQ is the number of gram equivalents divided by V, which is the volume in liters. And if we convert the equivalents into milli equivalents and the volume in liters to be ml, so it is basically 10 power minus 3 and 10 power minus 3, right? So it is going to remain the same. So we can write the normality as milli equivalents over the volume in ml also. Now the number of equivalents, what is that? It is basically the weight of the solute in grams divided by the equivalent weight. So you can replace the number of equivalents in this form. So you will get the normality to be weight of the solute in grams divided by the equivalent weight of the solute in grams and divided by the volume in liters. And now what is strength? Strength is basically the weight of the solute per unit volume, right? So the unit volume, if we take it to be liters, the weight of the solute in grams, so we will have the strength in grams per liter. So we can put this weight of the solute in grams divided by the volume in liters as strength in grams per liter. So we will have normality as strength in grams per liter divided by the equivalent weight of the solute. So I hope all these formulas are very clear to you, because you are going to use them in the numerical. So you should understand them and you should learn them really very well. And now the units of normality is normal, which is denoted by N. So what do we mean by one normal solution? So basically it is the normal solution of a substance is that which contains 1 gram equivalent of it per liter of the solution. Okay, so 1 gram equivalent divided by 1 liter is equal to 1 normal. Now we have important relations related to normality, just similar to molarity. So in molarity, we did do the dilution law, where we were diluting a solution by adding the solvent. So what was that dilution law? So the dilution law said that M1V1 is equal to M2V2. So in normality, we have N1V1 equal to N2V2. Similarly, the mixing law, when we were mixing two different concentration solutions, so there we had was that the final molarity was equal to M1V1 plus M2V2 over V1 plus V2. So here we have the final molarity of the mix to be N1V1 plus N2V2 over V1 plus V2. And then
a very important relationship had to be established between normality and molarity, right? So only if this is possible, then we can do a question when we have given normality, find molarity, given molarity, find normality. So for such questions, we have to establish the relationship between normality and molarity. So we already know that the number of equivalents is equal to the number of moles into the Z factor. Now divide this throughout by the volume V. What do we get? We get EQ, the number of equivalents, divided by the volume if it is in liters, and then N, the number of moles, multiplied by Z divided by the volume in liters. Can you identify what is this? This is number of equivalents per liter of the solution. So what is this? This is basically normality. And number of moles per liter of the solution, what is this? This is molarity. So what do we get? We get normality is equal to molarity into the Z factor, a very important relationship. Please do remember. So now again, let us do a few questions on the concept of normality. So calculate the normality of a solution obtained by dissolving 6.3 gram of hydrated oxalic acid in 250 ml of water. So the oxalic acid formula is given to us to be COOH whole twice dot 2 water. So the molar mass of oxalic acid, if you'll calculate, this comes up to 126, and you can see that the number of ionizable H ions in oxalic acid is how many? Yes, it is 2, because the number of H ions directly attached to oxygen is 2. So we have the number of replaceable H ions or the ionizable H ions to be 2. So the equivalent weight of oxalic acid is 126 divided by the Z factor, which is the number of ionizable H ions. So we get the equivalent weight of oxalic acid to be 63. And the mass of oxalic acid dissolved in 250 ml solution is 6.3. So per liter solution, it is going to be 25.2 grams per liter. And then if you divide this by the equivalent mass, you will get as 0.4 gram equivalents per liter, and this is nothing but the normality. So the normality of the solution is 0.4 normal. The next we have is to calculate the normality of a solution obtained by mixing 10 ml of N by 5 HCl and 30 ml of N by 10 HCl. So this is a question of simple mixing. So we will use the relationship final molarity is equal to N1V1 plus N2V2 over V1 plus V2. So this is going to be a simple one. Just put the values. You get the final normality to be N by. The next question says that 20 ml of a solution of H₂SO4 containing 4.9 gram per liter require 20 ml of 0.1 normal NaOH solution. Calculate the equivalent weight of H₂SO4. So we have the strength of H₂SO4 to be 4.9 gram per liter. Then we have 20 ml of N1H₂SO4 neutralized by 20 ml of 0.1 normal NaOH, right? So this is all which is given to us. So we can say that N1V1 equal to N2V2, the neutralization of acid by base, right? So the number of equivalents is going to be the same. So we have N1 into 20 is equal to 0.1 into 20. So we get the normality of H₂SO4 to be 0.1 normal. But you now know that the normality is equal to number of equivalents per liter. So strength divided by the volume divided by the equivalent weight. So just simply dividing the strength per liter over normality, you get the equivalent weight of H₂SO4 to be 49. The next question says that 0.106 gram of a base is required for complete reaction of 20 ml of zero point 0.1 normal HCl. Calculate the equivalent weight of the base. So we have 20 ml of zero point 0.1 normal HCl. So this is being neutralized by 0.106 gram of the base. And if we have one normal solution, so this would require how much base? 1.06 grams. And if we have 1000 ml of this one normal HCl, how much base would be required? This would be 53 grams. Now, what is basically 1000 ml of one normal HCl? This contains 1 gram equivalent of HCl. Why? Do you remember the definition of one normal solution? So, one normal solution consisted of 1 gram equivalent of the solute per liter of the solution, right? So if we have one normal solution, if we have 1 liter volume, then it is going to consist of 1 gram equivalent of HCl. And now 1 gram equivalent of HCl is going to be neutralized by how much base? 1 gram equivalent of the base. So we have 1 gram equivalent of the base to be 53 grams, which we have already calculated here. So the equivalent weight of the base is going to be 53. So one more interesting question for you. We have 0.25 gram of a dibasic organic acid dissolved in water, volume made up to 100 ml. And then from this solution, we are taking 10 ml. And this requires 12.5 ml of N by 30 NaOH solution for complete neutralization. We have to calculate the molar mass of the acid. So we have the base and the acid. So N1V1 is equal to N2V2, and you have 10 ml of the acid. You do not know the normality. For the base, you have the volume as well as the normality. So you can calculate the normality of the acid. So this is going to come up to 12.5 divided by 300 normal, right? So now this solution is basically made up from this part, right? So the normality is going to remain the same. So we have normality is equal to equivalent weight divided by number of equivalents divided by the volume. So the number of equivalents is weight over equivalent weight. So now we can put all the values we have. So we have the weight of the salt to be 0.25 gram. The equivalent weight we do not know. The volume which was taken for this 0.25 gram is 100 ml. So volume we will take as 100 ml, and normality we've already calculated. So we can calculate the equivalent weight from this to be 60. And now the question again says that it was a dibasic acid. To calculate the molar mass from the equivalent mass, you need to know the Z factor. So the Z factor or the basicity of this acid being dibasic is 2. So we get the molar mass to be 60 into 2, that is 120. So I hope you have enjoyed this concept. It is a very simple one and an interesting one. Helps make this calculation really very easy. So try doing your calculations with the help of equivalence concept. Solve as many questions as you can. If you are facing any difficulty, you can put that in the comment section or mail us at h2ochemistry@gmail.com. We'll be really glad to help you all. So now if you've liked the lecture, do please click on the like link. Also do subscribe to the channel and also the bell icon so that you get a notification as and when we put up a new lecture for you. So we would be meeting again for the next lecture, that is lecture 14, on the topic Stoichiometry, which is a topic for JEE Advanced and other higher competitive exams like NEET and GATE. I hope you really enjoyed this also with us. So stay tuned to us. Do subscribe to the channel to get a notification for the next lecture. Bye bye. Thank you. Have a nice day.